Hello everyone, welcome to today's session on matrix algebra. In this video, we are going to dive into the fundamental concept of matrix, specifically looking at the different type of matrices that are commonly used in mathematics. So, what is our goal for today? By the end of this session, you will be able to identify and understand the various types of matrices that exist. This foundation is crucial before we move on to more complex matrix operations. So, first thing first, let's answer the big question. What is a matrix? Simply put, a matrix is a collection of numbers or variables arranged in rows and columns to form a rectangular shape. If a matrix A has rows and n column, we say it has an order of m times n matrix, and it's denoted by a m times n, with aig is the matrix element A in I row and G column. For example, here um, we got a matrix that have 2 rows and 3 columns. So we call this a matrix of order 2 times 3. Next, now let's look at specific type. First up is row matrix. As the name suggests, this is a matrix that consists of only one single row. It has an order of 1 times 3. Not like before, we got 2 times 3 or etc. Here, we got always 1 times something. For example, here, we got A equal to 251. Because it's just a single line of number, we also often call this row vector. You can see example here like matrix A. So here there's a lot of example here. For example, for the first one that I already mentioned, and then the second one, A equal to 364, and then etc. Next, we got the opposite one is the row matrix. Uh, I'm sorry, it's column matrix. So, is it this is the opposite of the row matrix? Is column matrix. This is a matrix that has only one single column with an order of something times 1. Similar to the previous type, we also refer to this as column vectors. In the example shown, matrix A is a column stack of number 1, 4, 5, and here there's B stack number 5 and 7. Next, we got square matrix. This is very important in algebra. A matrix is square if it has the exact same number of row and column. If the number of row and column is same, we say it is a square matrix of order n times n. For example, here we got a 3 times 3 matrix, and this 3 times 3 matrix make it a perfect square. So that's why we call it a square matrix. Next, we got diagonal matrix. This is a special type of square matrix. Here's the rule. Look at the main diagonal that represent the number running from the top left to the bottom right. In a diagonal matrix, only this element have value that are not zero. Every other element outside of this main diagonal must be zero. And then next we have identity matrix. It's actually same as diagonal matrix, but the difference is just contain 1 and 0. And the number 1 is replace all the value on the diagonal matrix to be 1. And it is always has order of 3 times 3. So keep it in mind.
Thank you, Hamam, for the chances. Right now, I'm going to be explaining more about the type of matrix, starting from scalar matrix. So, scalar matrix is a development of the identity matrix. So, scalar matrix also still includes the main diagonal. So, the main diagonal, it's gonna be equals to k, with k is not equals to 0. It's gonna be anything else than 0. So for example, minus 1, 2, 3, 4, and so on. A scalar matrix can also be defined as a multiple of identity matrix. So for example, here k equals to identity matrix. So we know from the previous type identity matrix is like the main diagonal is equals to 1. So when it's times by variable of k, the 1, the main diagonal is gonna be all k. So yeah, like that. Next we have symmetric matrix. So a matrix is called symmetric matrix if it's a square matrix and its elements are symmetric with respect to the main diagonal. So this means like the element in the I row and the I row and j column is equals to the element in the j row and a column. So for example here we have the matrix B. So when the row in the first row we have here 1 2 minus 1, it's gonna be equals to the first column like here. It's also gonna be 1 2 and then minus 1. Next for other example we have the second row, we have 2 4 3, it's also gonna be equals to the second column. Here we have 2 4 3 and so on. So next we have skew symmetric matrix. So a skew symmetric matrix is a square matrix where the transpose of the original matrix is gonna be equals to the negative of the original matrix. So for example, when A is being transposed, it's gonna be equals to the negative of A. So in this skew symmetric matrix, we have a main condition that needs to be satisfied, which is the main diagonal needs to be 0. If the main diagonal is not equals to 0, it's not it's not gonna be a skew symmetric matrix. So here we have an example. Yeah, we have a matrix C. So we have when the main diagonal is gonna be equals to 0, we're gonna go to see if this C transpose is gonna be equals to negative of C or not. So when we transpose this matrix, it's gonna be 0, 6 minus 2, minus 6, 0, minus 4, and then 2, 4, 0. That's, so this is the transpose of the matrix C. Does it gonna be the same when we negative the original matrix? Let's see. So when we negative the original matrix, it's gonna be 0, 6 minus 2, minus 6, 0, minus 4, 2, 4, and 0. So it's the same. That means this is a symmetric matrix. But we have other example here. By here, we have the matrix D, which is 1, 2, minus 1, 2, 4, 3, minus 1, 3, 5. We need to transpose the matrix. So we have now we have the D transpose, which is gonna be 1, 2, minus 1, 2, 4, 3, and then minus 1, 3, 5. So thus the transpose gonna be the same as the negative of T. Let's see. When we negative the matrix of T, it's gonna be equals to minus 1, minus 2, 1, minus 2, minus 4, minus 3, 1, minus 3, minus 5. So these two are not the same. That means it's not a symmetric matrix. Next, we have a null matrix. So a null matrix, like the name, null. So if it's a square matrix and all its elements are equals to 0. Usually the null matrix uh, is to represent the concept of 0 in the matrix operation. So all the elements inside the matrix is going to be equals to 0, like here. For example, right here we have the A matrix 2 by 2, but the elements in it equals to 0, and then the B matrix for 3 by 3, it's going to be also all the elements equals to 0. Next, we have the upper triangular matrix. So upper triangular matrix is a square matrix which all elements below the main diagonal can be have the value of 0. So we already know that the main diagonal is here, like the 3, 2, 2. So below this number needs to be all equals to 0 for it to be upper triangular matrix. So why is it called the upper triangular matrix? It's because it's like the upper triangle. It's only the upper triangle that have a value on the matrix, but the lower doesn't have the value or the value is equals to 0. Next, the lower triangular matrix. So lower triangular matrix is the opposite of the upper triangular matrix. So lower triangular matrix is when a square matrix in which elements above the main diagonal matrix are equals to 0. So above the main diagonal needs to be all equals to 0. So it's gonna be only the lower triangle that have the value on the matrix. Oh, that's it for the explanation of the material. After this, Rajendra, our friend, can explain the Python code for identifying the type of matrix. Thank you.
Hello everyone, my name is Rajendra and I'm from the same group as the previous presenter, Hamam and Zaki. Now I'm gonna be explaining the program that we have made to implement what we've learned into this program, which is a program that can identify a type of matrix. when we input it. Now here we have a new function that identifies the matrix types, which I've listed here. We have 11 types of matrix right now. And also we use NumPy and tkinter as the only library that can run this program, that creates this program. Now I don't think there's a lot of explanation on this code except for a few features which I'm gonna be showing after I demonstrate the application. So right now we can just start the program. Here we have a GUI, matrix type identifier. Now we can create whatever we like with this input. We can make 3x5 matrix or basically anything. You just have to put the number. Now here we can actually fill the values here in the matrix itself. But for now, I think I'm gonna use the load example feature. It randomly loads a type of matrix that is included in the code here, but a lot of it is only 3x3 though. Although for exception, the row and column matrix right here. Now then, I'm gonna be continuing the program. As you input the values for the matrix, you can just click identify a matrix type, and then the output will be right down here with the dimension stated and the identified types. So for this case, it's a skew symmetric matrix. For another instance, you can load this. This one is an upper triangular matrix. So yeah, that's the features that we're gonna show in this basic program, Python program. And then yeah, I think that's basically it. It's just a program that can identify types of matrix when inputted. Well, without further ado, I guess that's all. We kindly thank you for your time and attention to watch this video as our last project for matrix algebra class. And me personally, I want to thank you all, and goodbye.